sulfur, when it cools and when it heats up, changes color. And this process is going on all the time on Io, so Io's surface is changing color all the time. And so this is on page 126. The volcanoes of Io were predicted before they were discovered by Stanton Peele and his co-workers, who calculated the tides that would be raised in the solid interior of Io by the combined poles of the nearby moon Europa and the giant planet Jupiter. They found that the rocks inside Io should have been melted not by radioactivity but by tides. That much of the interior of Io should be liquid. It now seems likely that the volcanoes of Io are tapping an underground ocean of liquid sulfur, melted and concentrated near the surface. When solid sulfur is heated a little past the normal boiling point of water to about 150 in Celsius, it melts and changes color. The higher the temperature, the deeper the color. If the molten sulfur is quickly cooled, it retains its color. The pattern of colors that we see on Io resembles closely what we would expect if rivers and torrents and sheets of molten sulfur were pouring out of the mouths of the volcanoes. Black sulfur the hottest near the top of the volcano, red and orange including the rivers nearby, and great plains covered by yellow sulfur at a greater remove. The surface of Io is changing on a time scale of months. Maps will have to be issued regularly, like weather reports on Earth. Those future explorers on Io will have to keep their wits about them. So that's interesting about Io, different changing color every few months. You've got your lawn is now black or yellow or whatever, just based on these almost like it's being ground between Jupiter and this other Europa moon. These tides are constantly belting out sulfur and then cooling into different colors. And again, even more interesting, what if you lived on Jupiter? You would then see every few months Io would be a different color. The moon would be a different color. This is on page 127. As seen from the near sides of Io or Europa, that immense invariable world fills much of the sky, hanging aloft never to rise or set, because almost every satellite in the solar system keeps a constant face to its planet, as the moon does to the Earth. Jupiter will be a source of continuing provocation and excitement for the future human explorers of the Jovian moons. So if you lived on Io or Europa, you have a giant Jupiter sitting there, and apparently the spins on these planets are really low. So all day, I guess day would be I guess if the spin's really low, then you're going to have really long days and really long nights. But you may also be seeing Jupiter all year. It's just right there, and it's going to be huge. Like the moon is a lot smaller compared to the Earth, but if you were on a moon around Jupiter is going to be huge. It might fill half your sky. So that would be really odd, really different place. So another point about Jupiter could have been a sun if it was a little bigger. And we would have had a dual sun. I can't remember what they call that, but there's a phrase for that. We would have had a dual sun solar system. This is on page 127. As the solar system condensed out of interstellar gas and dust, Jupiter acquired most of the matter that was not ejected into interstellar space and did not fall inward to form the Sun. Had Jupiter been several dozen times more massive, the matter in its interior would have undergone thermonuclear reactions, and Jupiter would have begun to shine by its own light. The largest planet is a star that failed. It was an interesting little ending for that. Had it become a star in visible light, we would today inhabit a binary or double star system with two suns in our sky, and the nights would come more rarely, a commonplace, I believe, in countless solar systems throughout the Milky Way galaxy. We would doubtless think the circumstance is natural and lovely. So he's saying here that we could have been in a solar system with two suns, and we would know the difference, and there'd be no night. Would be, well, geez, like when primitive tribes are roaming around the earth, nighttime would probably be some curse or something, and there'd probably be war and nastiness, and just like you hear, I don't know, I think it's true, but apparently during full moons there's weird activity, statistically more crime and things like that. So if we lived in a binary system, during the rare night, maybe once a month or maybe once a quarter, there'd be night. There'd be weird stuff going on our planet. But that would be interesting to live by those two the light from those two suns. We'd have a day. We'd probably still have a day like the sun gives us a day, and it's fairly bright out. And then we'd have some kind of distant day or something, or weekday, or I don't know, some kind of like day light, LITE, like, and after 6 o'clock or after 8 o'clock, it would still be light out, but it would be a lot less light, and maybe we'd call it something a little bit different. It'd be like evening. It'd be like dawn, but dawn for 3 hours or 4 hours. Well, maybe, I guess, 10 hours. But that we would still sleep during that time. And maybe even people would not feel so bad about doing night jobs, and there'd be some different things going on our planet if we had a binary system going on with two different suns. But anyways, that's possible, and as Sagan is saying here, in many solar systems in the universe, that is the reality. And I wonder how that would change the life that would exist on that planet. It would be a warmer planet, but based on the location of the planet, it may not be warmer. It could still be temperate. And it may indeed have more life on it if there's more energy reaching the planet through light. And it may also expand. You may have heard of, I can't remember what it's called. There's a term for it, but there's a band in our universe where a planet has to be to create life. There's like a habitable band, and of course we're in it, and Mars is just barely in it. If there's a binary system, like let's say Jupiter was a sun, then that band would enlarge. So if there is a binary system, it maybe, I guess it's a speculation, a binary system should have a greater capacity, a greater chance of holding life on some of its planets. That's just a speculation, but it certainly depends on the size of the two suns, because it's possible that the suns are so big that they just cook everything, and so your habitable zone is 0 because it's just too much. But it's also possible that if the suns are maybe medium, maybe like our sun apparently is a medium-sized sun, and Jupiter will be a smaller sun, then maybe the band would be wider. But if you have huge suns, then that maybe not work. You'd cook everything, and there'd be no habitable band. Anyways, those are just speculations, but still very interesting about what things could have been.